Hello all, this is Dr. A. Anuja, Assistant Professor, Department of Mathematics, Arulmigu Palani Andavar, Arts College for Women, Palani. In this lecture, we are going to discuss about two concepts. Those are first coefficients of friction. So, we know that limiting frictions between two bodies be as a constant ratio to normal reactions between them. So, the ratio of the limiting friction to the normal reaction, which is called the coefficient of friction. Here, we denoting coefficient of friction is a mu. Let F be the friction and R be the normal reactions between the two bodies. When those are in equilibrium, the equilibrium is in limiting. So we can written as F by R is equal to mu. Here F is represent the friction and R is the normal reactions and mu is the coefficient of friction. So we are equating this, we take R as on right side, so we'll multiple with the coefficient of friction, so we get F is equal to mu R. So the constant mu depends on the nature of the materials in a contact. So if we're different for different pairs of substance, it's ordinary less than the unity. So since friction is maximum when it is in a limiting, suppose mu R is maximum value of friction. So, when equilibrium is non-limiting and the friction is less than the mu R, which means product of the coefficient of friction and the normal reactions, and F by R is less than mu. So, the important points, in limiting equilibrium, the friction and normal reactions both vary the masses of the bodies even for the same pair of substance, but their ratios F by R is constant, being equal to the coefficient of friction. And in next one, we must not assume the friction is always equal to the product of the coefficient of friction and the normal reaction. It has the value only when motion is about to take a place. Otherwise, any value from 0 up to mu r it has. The next concept, angle of friction. Suppose one body kept in equilibrium by friction on another, and the point of contact Q, two forces acting on the first body. So we are considering two forces acting on the first body. So the two forces are normal reaction and the force of friction. These two are acting in perpendicular directions and they can be compounded into a single force. This single force is called the resultant reactions or otherwise called total reactions. In this figure, we denote F is a friction along OA. In figure 1, F is a friction along OA and OB is and R is a normal reactions along OB. These two forces acting at O, which will produce one single force along OC. So let OA vector is equal to F and the force of friction and OB vector is equal to R, that is a normal reactions. Let OC vector be the resultant of F and R. So in this figure 1, the angle or forming O is an angle of BOC is equal to theta. Now take tan theta is equal to BC divided by OB for the triangle BOC equal to BCE divided by OB. BC is equal to OA. BC is equal to OA because opposite sides are equal. So OA is nothing but the friction F and OB is nothing but the normal reactions R. So we'll get F by R. This is equation number 1. As F increases from 0, the value of theta increases until the friction F reaches its maximum value. So in this case, the equilibrium is limiting and the angle made by the resultant reactions with the normal, so which is called the angle of friction. The angle of friction is denoted as lambda. Here, the greatest value of theta is lambda, so which means the greatest value of angle is angle of friction. When one body is in limiting equilibrium over another, the angle which the resultant reaction makes with the normal at the point of contact, it's called the angle of friction and it's denoted by the lambda. See, in the figure 2, and OA, it's represent the product of coefficient of friction and the normal reactions, which means mu r along the point along the side OA and the normal reactions along OB. And the triangle BOC, it makes an angle lambda. Here OA vector represent the limiting friction, which is mu r, and mu be the coefficient of friction, and OC vector is the resultant of OA vector and OB vector. And also I told angle BOC is equal to lambda, and lambda is nothing but angle of frictions. Now we are forming tan lambda, it's equal to BC divided by OB, and opposite sides are equal in that figure 2. So BC as an OA divided by OB, and OA is nothing but limiting friction mu r divided by normal reaction r. So we are cancelling the r's on the numerator and denominator. Finally we will get mu. Mu is nothing but the coefficient of friction. So therefore the coefficient of friction, it's equal to the tangent of the angle of friction. So that is tan lambda is equal to mu. Thank you.